Okay. And welcome to another live stream. This time we're going to talk about cuts and choice point control. So I have here a so let me get organized and come all the way up to the top here, and I have defined my own version of member. And okay, what I'm going to make it my member so we know it's actually the one I wrote. And okay, HW, this is going to be available on recording if you get too far behind. So here I've got my own little version of member. It works about like you would expect. That is, something is a member of a list if it's the first element of the list, or if it's a member of the rest of the list. So let's find out. Here I have, this is actually a chars string if you did the primitives exercise. Here, let's query and find out if A is in the string abracadabra. And it says it is. And then since Prolog returns proofs, and there's lots of ways to prove that A is a member of abracadabra. The first character, the fourth character, the sixth, the eighth, and the 11th characters. So it gives us all of these proofs, and we probably just want to find out if A is a member. We might want, for example, to get all the solutions by backtracking. This is reasonable, and actually I used member, not my member. Sorry, but I'll get the same result. Okay, and mine eventually says false when it has no more solutions. Member is a predicate in SWI-Prolog. So here, how can we prevent all these extra solutions? We could use the cut operator. The cut operator trims away all choice points since we entered the predicate. Okay, so here I'm going to define my member check. And by the way, member check, CHK, is indeed a Prolog predicate. Because, you know, in this case, we just want to know if there's an A in it. We don't want all of these repeated solutions to A. So my member check gives us a single solution. What did we do here? We called my member, which is going to give us a bunch of choice points. We're going to have a choice point that has lots of options. And then we're going to run the cut, which trims everything since we entered this predicate. It trims all those choice points. So let's watch this in the debugger. Debugger. Are we getting all of this? Yeah. I'm going to step in, and I step in, and it finds the first one, and now it's going to throw that away, that choice point. Hang on, I'm going to redo this. I'm going to hit the R. Okay. I have a choice, stack frame 10 up here, because there are two possible entries, there are two clauses, and so it leaves a choice point behind. But the truth is, I don't need this choice point. I only want to know about the first occurrence of A. I don't need to look through this list. So I will use the cut operator, which simply destroys every choice point since I entered member check. Okay, so feel free to ask questions in the chat. I am watching it, and we get a single one. Let's try going back and looking at my member in gtrace. Okay. I'll look at the second solution, and this time it's going to go down through the list. You can see Y is becoming shorter as it descends through stack frames until it finds A again, and then it'll back up. So we're actually doing a fair amount of computation each time, at least if you were, running this in production. And then it's going to get worse each time. This time it's going to go all the way down, and this time we're way down in the list, and now we have to come all the way back up, and so we probably don't want to do this. Sorry about that. Running member check improves our efficiency and cuts out those unnecessary proofs. Okay, so at this point I've been a little fast and loose. So this is the definition of what cut does. It succeeds. Cut always succeeds. and it commits Prolog to that all choices made since the parent goal was called. So let's look here. So member check has so as soon as we enter member check, then any goal that was created after that instance, or any choice point created past that instance, is destroyed. We are committing. That's what it is to destroy a choice, right? You select a major in college, you're destroying a choice. I'm a little late in my career to be becoming an expert on French literature. And you make that choice harder when you select you commit to something when you just pick a major. Every major is terrible. So cuts have two effects. The first is that they tell Prolog not to consider any later clauses. Here's Factorial. And let's try a version without this cut in it. I will explain in a minute why it's green. Let's try, here's my Factorial, and well, it's not 0, n is 4. I'm computing Factorial of 4. So I have in and okay. Now, of course, Factorial is a recursively defined function. The factorial of 4 is 4 times the factorial of 3. And we're still not at 1. The factorial of 1, excuse me, the factorial of 0 is 1. So we're not there. So we will step in. By the way, most programmers would have written this 0, 1, but I actually needed to create that choice point. So notice that we are getting a bit of a call stack going here. And now, whoops, I stepped over. Sorry about that. Alright, it was probably just all to the well. I think you've gotten the drift. Notice that now we have a choice point. The choice point was all the way back at the bottom. I'll tell you what, I realized I could hit R and just step into that particular instance and undo my error here of my ways. Okay, n is 1, m is 0. Oh, and now look, this one is going to succeed. Now, as humans, we can see that with when, although there's a choice point here, the other clause is doomed because, or this is going to be doomed next time. It's a false choice point. this is a false choice. We really don't need to come back and revisit it. But we've got the choice point, and so and many of you asked me about this week. You're getting multiple solutions, and this is generally not what we want, is to have it give me another possible answer. There's a single valued function. There's no point in this. And of course, now we're going to go all the way back to the choice point. We're going to try the other option, the second clause. And it's going to fail. And now we'll unwind the stack. We'll do a bunch of extra work and give a bogus choice point. If you're whoops, sorry about that. I didn't go far enough. If you are writing Prolog code for real, leaving additional choice points around is definitely a code smell. Your APIs, internally there are times to do it, but coming back and leaving a choice point on the stack, unless you actually, that's your intended behavior, is not so cool. So this would not be an acceptable solution for Factorial and production. So now let's look at this first effect. Okay, we can use a cut. We will put an exclamation point in here that will tell us that Prolog should not consider any later clauses, right? By the time we've found that n is 0, we don't need that clause for this iteration. We're going to use the upper clause. So we can put a cut in and avoid a spurious choice point. Okay, does that make sense to everybody? That first effect? I know there's considerable delay. I'm just going to keep talking, and I may have to come back if I see you come back. There's about 30-second delay before you see what I say. Okay, the second effect of a cut is that it prunes all choice points and alternative, it says solutions here, it's going to be alternative proofs for the goals ever since we entered this clause. So that is everything to its left. So if we have foo that presumably goes from x to y, x is in and y is out, then we go from x to a, and then a to b, and then b to c, and c to y. That's great. There's going to be a lot of backtracking if we have a large number of these A, B, C, and D's solutions. But suppose that we know that there's a unique solution for B. We just don't expect to see anything other than a single solution at that point. Or we know there is that any solution is fine, then we can place a cut at this point and not do the extra work of backtracking and not leave spurious choice points. Okay. There's making sense. Great. I'm glad it's making sense. There's a taxonomy to choice points by utility and by effect. By utility, the good, the bad, and the ugly of our title. A good choice point makes the program do what we want. The factorial choice point is a good choice point. A bad choice point introduces a bug, and an ugly choice point fixes a bad choice point, making the program work correctly but leaving it rather obscure. Okay, we call choice points, we give them colors, which is why they've been printed green and red, by their effect. Red choice points cut away all, may cut away solutions. That is, they actually change the output of the program. They change the logical meaning of the program. And in fact, red cuts are going to make your program not be logically pure. So even if you have no side effects, they are effectively a side effect. Green cuts will cut away proofs, but not solutions. Okay? Forgive me for going back and forth. I am trying to check the chat occasionally here. Now, the Prolog engine has some kind of conflicting goals. You, of course, want the basic Prolog implementation to run as fast as possible. And you want the compiler to run at a reasonable speed. But, and you only can be finitely smart with the compiler. And Prolog will make an attempt to avoid making choice points when it needn't. For example, we could insert an optimization in SWI-Prolog that isn't there that would check to see if the first thing is n equals 0 or n greater than 0, and effectively insert the choice point. That'd be something we could automate. It's such a special case, that's probably not a good thing to do. If Prolog's just being stupid, I mean, you know, it's programming, they're stupid. If Prolog's being stupid, then we generally call this a blue cut. And if you go looking for other Prologs, there are many of them out there. This is certainly one choice, but you know, one thing before you, when you're shopping for a Prolog, ask what all it garbage collects, and ask how smart it is about avoiding blue cuts. So a green cut is the example with Factorial is, and even more so the second example. You know, we can't expect Prolog to be that smart, so so those cuts are truly green, and then GRU cuts are either green or blue, and GRU cuts, they prune proofs, but they do not change the ultimate outcome of the program. They do not change the solutions. Okay. All right. So here we've inserted this cut, and we didn't really change anything other than, I mean, the factorial still just reports, you know, that the factorial of 4 is 24. It doesn't change the ultimate solution we get. It just doesn't do the false, so it removes a proof. Okay? All right, I'm going to check the chat. Everybody seems to be happy. I'll just keep going here until people are until somebody says something in the chat. Like I say, be aware it'll take 30 seconds before I see it at best. But okay. All right. Let's look at this is there are some places that are good red cuts. Thanks, HW. There are some places that are good red cuts. For example, if you're implementing if then else, this is a good way to do it. This is going to return take either its second argument. It's going to take its first argument. If it's 0, it's going to return its second argument plus 3 in its last argument. And if it's non-zero, if it's non-zero, it's going to return its second argument plus 3. If it's 0, it's going to return its first argument plus 3. This is a pretty good reason to do a red cut. Is it expresses the meaning, right? We've said, okay, if it's non-zero, then don't consider the other clause. That's as good as my English explanation. This has the by having a cut here, we're not going to consider the other clause, and so that's just as good. That eliminates us having to do an extra test to see if the if is 0 for this second clause. Okay. All right. Here's a bad example of a red cut. This is a thing that's supposed to define a person's what kind of pension they will get in some government pension scheme. And we're going to ask, well, we ought to be able to reasonably ask if Joe gets nothing, right? But and if this was purely logical, you'd think it would work. But I'll tell you what, I'm going to gtrace into this. oh, okay. It turns out that it doesn't match this one, because that one's the rule for disability. That's the rule for Social Security. It's the rule for supplemental. And then here's the rule for nothing. So all of these cuts that we expected to keep us out of the nothing are ignored, and we report that yes, Joe gets nothing. Now let's go back and look at the code and kind of think out, well, Joe is over 65 and he's disabled, and he contributed to the fund. So, well, gosh, he ought to get a disabled pension, shouldn't he? And then, that's the one he should get. And in fact, if we ask what pension Joe gets, now it picks up the disability, and it works properly. So that's a bad red cut, because it complicates your meaning. In a sense, you've still got some meaning here. Joe has, if he has a disability, then he gets if he's disabled, he gets a disability pension. If not, and we don't need to look further. If he gets if he's over 65 and contributed, he gets Social Security, and we don't need to look further. I can imagine somebody who did this by hand and then eventually decides to automate it, writing this bit of code, and all day people come in and say, what kind of Social Security or what kind of pension can I get? And nobody prefers nothing. So this works as long as your first argument is bound. But if you try and bind both arguments and your second is unbound, if you try it in the other mode, though, with the first bound and the second unbound, then, as we saw, we have a bug. So it's not true that Joe gets nothing. Joe gets a disability pension. Okay? So this is... you thought all red cuts are bad. The truth is that it's that while all red cuts will make your program non-logical, but certainly if you're writing production code, you want your program to be efficient, and yeah, a cut is always something to avoid, but if it's that or returning an extra choice point, use the cut. Definitely, cuts are always far better. I noticed Jan actually uses. There's an operator. I'll type it into chat. This if operator, which of course would have been an option. You can say if first thing is succeeds, then then prove second thing, otherwise prove third thing. That operator is excuse me. That operator doesn't have a cut on the surface, and I noticed it's actually something Jan does all the time, and has used that operator. I find that it's kind of dangerous. Yeah, sorry about the sneeze. It's kind of dangerous in that it actually is a cut underneath. You've just seen the underlying code for that in the if then else. So you're not really avoiding a cut, and it's so I tend to do it the other way. I tend to just use the cut, and I'm pretty liberal with cuts. Prolog's a practical language, and yes, its cuts are impure. So, it's kind of like output. I mean, if you're going to say avoid all red cuts, then you're also, are you also going to say avoid all output? That's going to be particularly painful. But yeah, but they're impure and effectively a side effect. So a cut will make the order, specifically a cut makes the order important. Okay? All right. So, okay. And then we've talked about good red cuts and bad red cuts. Ugly is, ugly is that we fix up I mean, unfortunately, Prolog, I'm responding to Brian here, who says, okay, I guess I just misunderstood the original explanation of red, green, and blue. If you while red cuts will make your program be non-logical, they will make the order in which you do things important. The ordering on the file, in the file. That just kind of comes with the territory, and that doesn't mean you shouldn't never do them. Prolog is a Prolog has suffered from the fact that I'll tell you, there are in the hundreds or possibly somewhere below 1,000 to maybe 5,000 people professionally writing Prolog at the moment. There are every semester there are thousands and thousands of undergraduates who get 2 weeks of Prolog in an undergrad programming language class. And so they learn a very kind of theoretical version of Prolog, and this course is kind of a protest against that. And we will take what you've heard before with a grain of salt. It probably came from a rather academic perspective. We kind of share this. If you're familiar with the Haskell community, there's a little bit of the same thing goes on. Fortunately, Prolog tends to have less sort of hair splitting and more real progress, it feels like, at times. There's currently a fight going on, mostly a bad actor, but Okay, where were we? But yeah, take that with a grain of salt. Okay, when should you use a cut? I will. One is to tell Prolog you've found the right rule. You know, if you have a bunch of rules, and especially in that common case of I have several specialized cases and then I have the general rule, it's often just cleaner to put cuts on the specialized cases. Second reason is when you want to tell Prolog to fail. You know, like suppose you're doing a thing where you look up the person's current address, and as you're looking, imagine this is an old like paper system. We're digging through papers and we come across the person's death certificate. Well, we no longer need their address, right? You know, unless you think of them as living at their grave. But they don't have an address anymore. And then a third one, a very common pattern in Prolog is to generate something that might be a solution and then check to see if it is. And that pattern, of course, is going to it's going to have choice points for the generate portion, and you're going to oh, I had slides for these. Okay, it's going to generate parts for the generate solution, and then you're going to want to trim those when you find a solution. Okay, so this is the one I talked about. Tell Prolog you're at the right rule. If it ends 0, you're at the right rule. Don't use the second one. Give up now. Suppose I try my factorial with n less than 1. Here, let's go back here. And I'm going to try factorial -1f. And I better use, sorry, -1 and f. Okay, we're actually not going to get, well, n isn't 0, so, okay, well, I've got this at n greater than 0. Hang on, I forgot. I was supposed to remove that before doing this. Sorry, guys and gals and other folks. I did not do that. Okay, so all right, and now whoop. And of course I should have had the cut, right? But here I've got the problem that this isn't going to work. And now I am in an infinite loop. And I'm going to abort it. I hit A, by the way. And now I'm going to hit A. It'll abort, and then it'll ask me again what I want to do. And eventually I'll abort. Sorry, being a little bit scattered here. I should put my cut in. Okay, this is the one I wanted to show. Well, that's fine, but, you know, like I just showed, this is not going to, this is still going to have the same problem of, okay, well, that one will fail. And it's just going to keep counting down because it's trying to get to 0, but it's counting down, right? So n's just going to keep going, minus 12, minus 13, and we're headed for infinity. So I will abort. Sorry for the bungled demo. Okay, so this where was I? Sorry, okay, so how can we fix this problem with Factorial? Well, we could just plain give up, because really Factorial is not defined for negative numbers. So how about if we do this? Fail is a predicate that fails. And so I can test to see if n is less than 0, and if it is, I'll just fail. Yeah, if people are interested in what's going on, I'll post something in the somewhere in the course. So okay, now let's try running it. And now, oh, n is less than 0, so we should commit, which means we're not going to have any other choice points. We're not going to ever get into these two clauses, and then I'll fail. And I come back immediately. Yeah, I'll you know, why don't I make a little, it is unavoidably political, Prolog being a language with such a long history and such an academic history does not help it. The community can be very, it's very collegial. It's a bunch of academics, and I'm hoping, you know, it's a small group of people, and I'm hoping that one of the things that comes out of this class is that we get more users, and more users means we have a chance to make a community. So when you're interacting with each other, I really encourage you to remember that whatever you do is going to be what we do as a community, because it really is you folks at this point. Okay, so that fixes our problem here. Is we know at this point we have no solution, and we can give up, and then all right, and then the last one, of course, is terminating the generate and test pattern. So that is, for example, suppose I have some function I really, you know, I have a predicate that is in and out and is basically a function, and but it's not invertible. I can only call it from one to the other, and so I'm just going to guess numbers. By the way, there is a thing to guess numbers between gives you numbers. Yeah, between suppose I'm doing this and I'm looking for I don't know, a number that's a perfect square or something. When I find it, then I don't want to keep generating guesses, right? I lose my car keys. I'm not certain where I put my car keys. I look around the house and I find them on the kitchen table, I stop looking, right? So searching is often generate and test. Search in the kitchen. Search on my nightstand. Search, see if they're hanging in the front door lock. I think of places they might be, and then I look. Whoop. And hang on, I have to get my. Okay. So here's an example of that. Let's say I'm going to. I'm on a long drive, and I get tired of the silence in the car. I'm going to turn the radio on, but it really is just background noise for the drive. So I'm going to turn it on, and I'm going to start hitting the seek button, and I will start looking for a station because I don't want to listen to static, and if it's coming in okay, right, I don't want to listen to like weird distorted stuff, and if it's decent music, then fine, right? I don't want to listen to the whatever your definition of bad music is, but whatever. Okay, that's decent, and now I'm back to my driving. We often are in this kind of situation where we terminate, generate, and test. Okay, we're doing pretty good. I'm a little behind, but we're last 3 slides. Okay, I took this last little bit. I actually took a fair amount of this from Richard O'Keefe's The Craft of Prolog. So if you're looking for other sources here, his section on cuts in The Craft of Prolog is an excellent source. All right, so he suggests these rules for where to place a cut. Look for the right clause to use. And as soon as you know this is the right clause, then put the cut there, not later or earlier. Postpone output unifications until after the cut. So here we don't want to enforce output until we or we don't want to enforce having the output be the same as our variable until we are certain we're going to actually get to the end without doing some cuts. And here's an example. Max, this is very similar to the problem with Joe agreeing with nothing. This has a bug, and it says that 10 is greater than 0. Because one of the limits 10 is greater than 0, and then we do the cut. But now we've got the problem that it unified. So here, you want to not do the output unifications until after the cut. I guess I'm belaboring that. Okay. I've explained the rules for cuts, right? They remove all the choice points generated since we entered the since we entered the predicate, and hang on, I will put that back up. Sorry, I stopped to check the chat. Whoop, and I'm on the wrong slide. Okay, but you know, this could get kind of complicated. The semicolon is the disjunction operator. I'll cover that at some point here. By the way, I kind of caution you to shy away from it. And call takes a single argument, which is and executes it, queries it, and backslash plus is the is not provable operator, and find all constructs a list of all potential solution, or excuse me, all potential all potential solutions. No, excuse me, all potential proofs of its of whatever it repeatedly calls in the middle. The second argument is a callable thing here. So the question is, with all of this going on, all of these kind of meta predicates running around, where are what gets cut when? And Richard O'Keefe has a cool little mnemonic for remembering this. Cuts are blocked by letters. If the meta predicate uses letters, then it blocks the cut. So find all will treat this as a subgoal, and call will treat this as a subgoal, and cuts inside will be considered inside that. However, these two, 1 and 2, will be considered in the context of P. So this one will, that one will, and then and not provable will be considered in the context of P. Okay, and so you're not belaboring the max 1. Okay, I'll go back to the max 1 bug then. Okay, I did a poor job explaining it. My apologies. All right. Hang on, I'm gonna copy the code. I didn't actually get the code up. Okay. All right. Here's the code. And on the surface, it looks pretty reasonable. This is my version of a max function, which I'm going to compile. Oh, it has a singleton in it. That's actually a warning, and I can ignore it. Right. We all kind of implement. If you're in a language and you don't have max, you can always just write an if. All right, that's what somebody's attempted to do here. They've said with x and y, if x is greater than or equal to y, then it's going to be x. But then you want to short circuit claiming that y is bigger. So because if x is bigger than y, then the second one is not true, right? We don't want it to come back, so we need the cut. Or we'd need to implement another compare. But they chose to use a cut. There's a problem with doing this, and that is, hang on, I'm going to say max 1. And what if I use it to test? So I'm going to say, is 10 greater than 0? Which is 0 the max of 10 and 0? That was the bug. And I tell you what, I think I'll just gtrace into this. And this is not going to unify this first one. So that never gets called. So we evade the cut, even though x is 10 and y is 0. Well, then but x was not the same as x here. This was written assuming that our mode was out for the third argument, and I've called it in a mode that it's not expecting, right? I called it with and usually this, you should definitely try in your predicate to tolerate your predicate being used as a test at the very least. But in this case, we've fouled them up because the first and third arguments are not the same. 10 is not the same as 0. So we ignore this first clause, and now we test to see if it's the same as the second clause, and it is. So this succeeds. And it's going to say it's true that the max of 10 and 0 is 0, which is a bug, right? Did that help? I'm going to sit here and wait till somebody tells me that that either helped or they're still confused. Hey, at least one person says, oh, I got it. Okay, so that, yeah, okay. All right. So that was that problem. Just that's a way to bite yourself with a cut is that that it makes it non-logical, and it kind of complicates your thinking because, yep, yeah. Okay, folks, it's 4 after the hour, and I've completed my talk. Anybody want to ask me any questions? But otherwise, we're I think we're done, and you can go on. I knew this material was particularly intellectually challenging and hard to understand, and so I figured I would just kind of like do live sessions for this. Everybody happy? Okay. With that, then, I think I'll terminate the broadcast. Thank you all for coming, and I'll see you back on the Moodle or in the Slack. Great. Okay, see you, Tay. Tracing max 2 will be a fun exercise. I don't know what max 2 is, but yeah, yeah, see if you can fix this. That's actually a good exercise. If you want to do a little exercise, is to figure out how to fix my max one, other than the obvious fix of removing the cut and using a second condition. All right. That would be a good exercise. All right, I think we'll sign off. Thank you all for coming, and see you in class and on the Moodle. Bye, and on the Slack. If you're not using the Slack, definitely do. I think everybody who's on the Slack has found it really useful. I'll see ya. Bye-bye.